Hello, my name is Andrew Romans, and this is Project 2 of Artificial Intelligence, the decision tree. Start off here, the first thing you'll see is that the XML file or the tree has been printed out nice and neatly, so everything is indented where it should be. You'll see root has its three children, idle, incoming, projectile, combat, which then has their children. So idle has use computer and patrol response, evade for incoming projectile, a melee and ranged behavior, as well as a response for those flee attack, weapon 1, weapon 2, and weapon 3. Just real quick, if I was to add this code right here that I previously wrote up fast for the XML, it will then add it in perfectly fine, and it will also make sure to space it out properly. So I have behavior magic, dark magic, light magic, then for dark magic, sacrifice and taint enemies, as well as light magic, resurrect and heal teammate. So what the user can then do is pick a response or a behavior to choose a response from. So for instance, if I was to choose combat, it would then pick a random behavior from combat and then choose a random response from that. So it chose melee and then flee as the type combat in again, which if you type combat again, it'll pick a random one and it'll pick weapon 3, this time ranged. And it'll also, right after that, tell you the steps of breadth first search and then the steps for depth first search. Um, just type in magic there. See, we'll pick sacrifice. To show the steps. If I was to choose root, it would then go through, pick a random node of its children, and then random from there. So it happened to choose combat, which then went in and it chose ranged, which then went in and it chose weapon 2. It doesn't matter about spaces. It can be any space or any capitalization, I mean. Oops, that doesn't exist. And it should pop up. If you choose the response itself, it will pick that response. And if you pick a behavior node with just one child, it will pick that response as well. To quit, you can either type in quit or Q. And now we'll get into the code. So the way that I organized it, I created a node class that has name, parent, and visited property. I created a treelist class that has a list of nodes. It keeps track of the current node and recent node. You can create an empty list and then add nodes to that list, giving it its parent and name. You can remove nodes from the list, which removes the current node that it keeps track of. You can find all the children of a node. You can go to the next node, which sets current node to the next index of the list. Last node, which sets current node to the last index of that you are currently at. You can mark a node as visited. You could find the parent of a node. You could find the index of a node within the list, and you can print it out. Now to the program, and all of the code is commented, so if you wanted to read through it all yourself, every piece of the line is commented, so it should be easy to follow. Um, Starting off, I read the XML file and I add it to a list of strings. From there, I then print the tree and fill the tree list class. Um, so that's what gives you the neat and tidy properly tabbed um, list that you see here. And then it adds all of the proper behaviors and responses to this tree list, which makes life easier for me to search through. From here, I then go into a while loop, so waiting for the player to quit. Um, Once the player, it's the not player, but once the user has typed in the node he or she wants to search for, it starts the breadth and depth first search. Um, all the depth searches here. It goes through the nodes and then there's recursively. So when it doesn't find the node that it's looking for, it then goes to the next part of the list and it continues down, marking nodes visited, popping and pushing nodes to the stack, which I create here. And once it has found the node it was looking for, it will pop the node out, it will set it to find, and then it will start returning out of all of the recursive calls, out of the recursive calls that it was made. And if it doesn't find it, then it just says it couldn't find the node. In breadth search, it's very similar, except using a queue. It does all the same. It makes sure that the node exists, sets the current pointer to the current node in the list. If it finds the node, it returns out of returns out of all the recursive calls, sets breadth found equal to true, as well as finds the action response. An action response, it determines the number of children in a list. If the child list count is 1, then it returns that child because that's the only one to choose from. If there isn't any children of that node, then it returns that pointer itself that was there because that's the only thing it can pick from. If there is more than one child, then it takes the count and then it picks randomly between the two, between the numbers of the number of children there. So if there was 3, it would pick between those 3. Once it has found it, if it if it doesn't find the node, then it goes through recursively, recalling the same function. And if it can't find it, then it returns that it couldn't find the node and that the response is nothing since there is nothing there. And then it continues on until the user types in quit. Here's where it finds if the breadth and depth is found, then it gives you the response that it chose and it gives you the number of steps. And that's pretty much it. As I said before, the code is all commented, so if you wanted to take a closer look, you can do so. But other than that, I hope you enjoy.